practice. We'll leave an hour for practice. So if you have two functions, right? When you compose f with g of x, when you put g of x inside of f, you get x. And then when you put f of x inside of g, you also get x, where they're defined properly. These functions that do this are called inverse functions. In other words, when you compose two inverse functions with each other, you get the identity function. Okay? So y equals x is called the identity function. When you compose two inverse functions, if a pair of functions are inverse functions, you compare them, you get the identity function. Because what does it mean to be identity? You put x in, you get the same thing out. Okay? So the x value and the y value are the same. In other words, you put x in, you get back x out. Okay? Because the y is equal to the x, and that's called identity. And that is what inverse functions do. They compose to give you the identity. So in order to show that two functions are inverse of each other, you need to show that when you compose them in both directions, you get the identity. So let's look at this situation here. This is f of x. F of x is equal to 4x minus 7, and g of x is x plus 7 over 4. So if I take the g of x here, right, and I put it into f of x, okay? In other words, f of g of x. That's going to be, I'm going to put, anywhere I see an x, I'm going to put a g of x. So I'm going to put x plus 7 over 4 wherever x used to be. And I'm keeping my minus 7. All right? And so now I'm gonna do some calculation. Well, since the 4 here is on the side and the 4 is on the bottom, you can cancel them. And so what you're left with is x plus 7 minus 7, which is just going to be x. So I got x. So far I'm good on the left hand side. Now what happens when I take g and I input f? So I'm going to take my g, and wherever I see x, I'm going to put the 4x minus 7. So that's going to be 4x minus 7, right, wherever I see x, plus 7 over 4. But I really don't need the parentheses, right, because I'm just adding. So I don't need the parentheses. And so negative 7 plus 7 is 0. So what I'm left with here, excuse me please, is 4x over 4. So I got 4x over 4, which is equal to x again. So when you do the calculation, if you input g of x and you end up into f and you end up getting x, and if you input f of x into g and you end up getting x, then that means that these two functions here had to have been inverse of each other. Can somebody tell me, do you notice this? Let's look at this in terms of order of operations. Take a number, multiply it by 4 and subtract 7. You can take a number, x, multiply it by 4, subtract 7. Isn't the opposite of that would be to add 7? So you're coming back from subtracting 7, the last thing you did. Isn't the opposite adding 7? And then going backwards, wouldn't it be if instead of multiplying by 4, you divide by 4? Do you see it? So what they do is inverse functions undo each other. All right, so let's think about it. All right, so let's do an example. Find the inverse of this. So here, watch carefully now. Here's how you find the inverse of a function. So step 1. using this example, f of x equals 2x plus 7. So this is how you find the inverse of a function. Step 1 is, just a second, make sure I give you everything. Step 1 is to replace f of x with y. So you're going to replace f of x with y. So this function is basically just going to be seen as y is equal to 2x plus 7. So step 1 is just to replace f of x with y, if needs be, of course. Step 2 is to interchange x and y. So step 2 is to interchange x and y. So that means that wherever you see y, you're going to put x. So on the left you have y, so it's going to become x. And on the right you have x, so it's going to become y. Okay, got it? So instead of having a y equals 2x plus 7, you have x equals 2y plus 7. Okay? Alright. Okay, not done yet. Not done yet. We got a few more steps. Step 3. Step 3 is to solve for y. Solve for y. Okay, so I solve for y. There's some caveats here, but we're keeping it simple. So solve for y. So you're taking x equals 2y plus 7. You're solving for y. So means you subtract 7 from both sides. Alright, and so you get x minus 7 is equal to 2y. X minus 7 is 2y. And now you can divide by 2. Divide by 2. And you're going to get x minus 7 over 2. X minus 7 over 2 is equal to y. Alright, so that's step 3. And the fourth and final step. Fourth and final step is to replace y. Fourth and final step is to replace y with the inverse function symbol, f inverse of x. This does not mean f with an exponent of -1. It does not mean that. It just means f inverse. F inverse of x is going to be equal to, as we just saw, x minus 7 over 2. Okay. Yep. So that's that. All right. So by looking at a graph, we can know. By looking at a graph, we can also know whether or not a function has an inverse. We have to look at something called a horizontal line test. And it's simple. Draw a horizontal line. If the horizontal line touches the function at no more than 1 point. If the horizontal line touches a function at only 1 point, the horizontal line touches a function at only 1 point at most, then we have an inverse function. So let's look. We've got all the different color lines going through. All the different color lines going through this y equals x cubed function. Each of these lines crosses at 1 point. Therefore, this has an inverse. So f of x equals x cubed has an inverse over its domain. Over its domain. So f of x equals x cubed has an inverse over its domain. On the other hand, the absolute value of x has a problem here. If you look at the vertical lines, no matter how many vertical lines you put through, except for the one at the origin, these will not cross exactly once. They're going to cross 2 times. So y equals absolute value of x considered over its domain. Y equals absolute value of x considered over its domain will not get an inverse function, will not have an inverse function. Will not have an inverse. So if we think about the absolute value function over its domain, it will not have an inverse. Again, because it does not pass the horizontal line test. So there's no inverse here. Alright, finally, how are the graphs of the inverse function? How are the graphs of the inverse of an inverse function related to the function itself? Okay, so this is some graph here, right? Y equals f of x. This is its inverse. Y equals f inverse x. This is how they're related. If you look at y equals f of x, which I'm going to highlight in blue here. Y equals f of x here. Okay, in blue. And if you look at y equals f inverse of x, which I'll do in red, notice that they are symmetric. They're symmetric. There's a symmetry with respect to the line y equals x. So if you reflect the function over the line y equals x, you get its inverse, and vice versa. If you reflect the inverse, you get the function. So you can use reflection over the line y equals x to determine if 2 graphs you're looking at represent inverse functions that are inverse of each other. All right, so that's it. So we'll get a chance